Electric motors are the invisible engines that keep our world running. From the whisper of a ceiling fan to the hum of an electric vehicle, motors are everywhere, quietly converting electricity into motion with breathtaking precision. But what looks like a simple cylindrical object is actually a marvel of modern engineering, created in high-tech factories where copper, steel, and magnets come together in perfect harmony. Today, we're stepping inside one of these factories to see how electric motors are made, step by step, from raw materials to finished powerhouse. Chapter 1. The Blueprint of Motion. Every electric motor begins long before metal ever touches a machine. It starts with design, a digital blueprint engineered to deliver a specific torque, RPM, and voltage. Engineers use advanced CAD software to model every component with micrometer-level detail. These digital simulations calculate stress loads, thermal behavior, and electromagnetic efficiency under countless conditions. Whether it's for a smartphone vibration motor or a locomotive drive unit, the core principles remain the same. Once the specs are locked, the factory floor comes alive. Chapter 2. Shaping the core. Electrical steel laminations. The process begins with electrical steel, specially alloyed and treated for low energy loss and high magnetic permeability. Large coils of this steel arrive at the factory weighing several tons. These are unrolled, straightened, and passed through high-speed punching machines that stamp out incredibly thin discs called laminations, each less than half a millimeter thick. These laminations are then stacked and aligned to form the stator and rotor cores. The stacking process is done with robotic arms using laser-guided alignment systems, ensuring every disc lines up perfectly. Why laminations? Because solid cores would trap eddy currents and waste energy. By layering these insulated sheets, manufacturers reduce these losses and enhance motor efficiency. After stacking, the cores are laser welded or clamped to hold their shape permanently. This stage is all about precision. Just a few microns off can affect the motor's lifespan or create imbalance. Chapter 3. Copper, the veins of the motor. Next comes the most vital element in any electric motor, copper wire. This isn't ordinary copper. Factories use oxygen-free, high-conductivity copper delivered in enormous spools that can weigh over 500 kilograms each. The copper is drawn through a series of dies to reduce its diameter, sometimes down to less than a millimeter. Now the magic begins with coil winding. High-speed, computer-controlled winding machines loop thousands of turns of wire around the stator's slots. These machines operate at blinding speed but with surgical accuracy. Tension sensors, vision systems, and auto-correcting arms ensure that every winding is flawless. In higher-end motors, especially those used in aerospace or EVs, the coil windings are done manually by master technicians who bend and tuck each wire with tools resembling dental instruments. Chapter 4. Insulation and resin impregnation. After winding, the stator isn't ready just yet. The tightly wound copper needs protection. It's placed inside a vacuum pressure impregnation chamber, a massive sealed vessel where air is sucked out and insulating resin is pumped in. This process ensures that every air pocket, gap, and surface is flooded with resin, locking the wires in place and making them resistant to moisture, vibration, and thermal stress. Once soaked, the stator is baked in industrial ovens at temperatures exceeding 150 degrees Celsius. The resin cures, hardens, and creates a glass-like shield around each coil. The result is a solid, immovable core that can endure decades of operation, even under extreme conditions. Chapter 5. Rotor, the heart that spins now. It's time to build the rotor, the part that actually spins. In induction motors, this is typically a squirrel cage rotor made of laminated steel and cast aluminum or copper bars. Molten metal is injected into the rotor slots under pressure, and once it solidifies, it's machined to perfection. In permanent magnet motors, the process is even more delicate. Rare earth magnets like neodymium are embedded into the rotor core. These magnets are extremely powerful and brittle. Even a small mishandling can cause them to shatter or demagnetize. Using robotic placement arms and shielded cells, the magnets are installed with air gap accuracy. Each rotor is then placed in a balancing machine, spun at several thousand RPMs while sensors detect even the tiniest vibration. If an imbalance is detected, technicians make micro adjustments by grinding or adding balancing weights. Precision here is critical. At high speeds, even a half gram of imbalance can cause catastrophic failure. Chapter 6. Final Assembly and Testing. With the stator and rotor complete, it's time to bring the motor to life. Bearings, often ceramic or high-precision steel, are installed on both ends of the shaft to allow for smooth, frictionless rotation. The rotor is inserted into the stator with exact alignment using laser tools to ensure the air gap. The small space between rotor and stator is even all around. The housing is assembled around the motor, either from cast aluminum for lightweight applications or cast iron for industrial durability. End caps are fitted, seals are installed, and the entire motor is torqued to factory spec. If the motor uses active cooling, fans or liquid cooling jackets are integrated during this stage. Then comes the test bench. Every motor is tested for electrical resistance, insulation integrity, mechanical alignment, torque output, noise levels, and heat generation. Some motors are stress tested under simulated load conditions for hours at a time, while sensors log every millisecond of performance. Only those that meet 100% of spec are cleared for packaging. Chapter 7. Packing Power, Shipment and Global Deployment. Each finished motor is carefully cleaned, labeled, and logged into the factory's inventory system. Serial numbers, batch records, and test data are stored for traceability. The motors are then packed in anti-static, shock-resistant crates with desiccants to prevent moisture damage during transit. From here, they're shipped across the globe, headed for factories, EV assembly lines, escalators, medical devices, and even spacecraft. It's the final step in a journey that transforms raw materials into one of the most reliable machines ever made. Chapter 8. The Beating Heart of Progress. Electric motors are everywhere, and yet we almost never see them. They live behind the walls, inside our gadgets, under the hood, but without them, nothing moves. No elevators, no production lines, no electric cars, no robotics. They are the beating hearts of progress, quietly spinning the world forward. Every turn of a shaft, every hum of a motor is the result of decades of innovation, precision engineering, and a level of manufacturing perfection that borders on art. In a world increasingly dependent on clean energy and smart machines, electric motors are more vital than ever. So the next time your washing machine spins or your EV glides silently down the road, remember, there's a motor behind it. Built with purpose, crafted with care, powered by science. If this deep dive into the electric motor manufacturing process sparked your curiosity, make sure to give this video a thumbs up. Subscribe for more behind-the-scenes journeys into the factories shaping our world. Got a process you want us to explore next? Drop your ideas in the comments below. We're always listening. Thanks for watching. Until next time, keep learning, keep exploring, and stay curious.